Exponential functions. An exponential function is a function whose equation can be put in the form y equals a times b to the x, where a cannot be the number 0, b has to be a positive number, and b cannot be 1. So a few examples, like y equals 3 times 5 to the x would work. Or y equals, this first number could be a negative, it just can't be 0. And the base could be a fraction. There's nothing preventing that. Okay, so why are there these rules about a and b? Well, a can't be 0. That one's easy. A can't be 0 because if a is 0, we would have y equals 0 times b to the x, which would just be 0, which isn't a very interesting function. It happens to be linear, not a nice straight line. B can't be 1 for kind of the same reason. If b is 1, I would have y equals a times 1 to the x, but 1 to any power is 1. 1 times a would be a. Again, that would be linear. Now, b has to be positive. That one's a little bit harder, but not much. Let's say b is negative 4 and a is 1. So let's say we have y equals negative 4 to the x. The problem here would be is if we tried to plug in a number like x equals a half. We would get y equals negative 4 to the half. And we remember from previous stuff that a power of 1/2 is the same as the square root. And we would end up with imaginary numbers to I. So that's why b can't be a negative number. If b is a negative number, then you're going to end up with imaginary answers sometimes. Alright, so most of this section we're going to deal with graphing exponential functions. So we want to graph y equals 3 to the x, and after that we want to find the domain, the range, and this is something new to us, something called an asymptote. And we'll talk about these after we graph. Let's start down at the bottom of the table. 3 cubed, that's 27. 3 squared is 9. 3 to the 1 is 3. 3 to the 0, you remember our properties of exponents, we showed that 3 to the 0 is the number 1. And then we have 3 to the negative 1, and again, remember your properties of exponents, we showed that that turns into a fraction. A negative exponent drops things down to the bottom. So 3 to the negative 2 is going to do the same thing. That's going to be 1 over 3 squared, which is 1/9. And then 3 to the negative 3, that's 1 over 3 cubed, which is 1 over 27. Okay, so notice what's happening here. If I start using positive numbers, my answers get really big really fast. 3 to the 4th, if I plug the 4 in, that would be 81. 3 to the 5th, I don't know what that is. 243 maybe. Anyway, if I keep using positive numbers, my y values are going to get really, really big. On the other hand, if I keep using negative numbers, my y values are going to get really, really small, really, really close to 0, but they're never going to hit 0. I'm always going to have 1 over a positive number. It's going to get really close to 0, but never will be 0. Alright, so let's draw this graph here. 327, that's way up off the grid. 29. 1, 3. 0, 1. Negative 1, 1/3. Negative 2, 1/9. Negative 3, 1/27th. And you see what's happening there. Those dots are getting really, really close to 0, but they will never equal 0. I'll always have 1 over a positive number. So our graph has this shape. Like so. Okay, now domain. We haven't used this word in quite a while. Domain means what x numbers can you plug in? And we noticed we were able to plug in positive numbers. We were able to plug in 0. We were able to plug in negative numbers. Looks like we're able to plug in anything. Domain is all real numbers. Range means what kind of y numbers did you get? And if you look, the y numbers we got We're only positive. We'll never get 0, and we'll never get a negative number. Y is greater than 0. And then asymptote. This is a new word for us. Notice what's happening as we come this way. This graph keeps coming down and down and down. It keeps getting closer and closer and closer to this axis, but we'll never actually touch it. And that's what an asymptote means. It means a line or a curve that a graph approaches but doesn't touch. In this case, it's the x-axis, and the equation of the x-axis is y equals 0. Alright, this kind of function, where it goes, curves and goes upward like this, we call this exponential growth. That general shape. Alright, let's look at another example here. Y equals 4 times 1/2 to the x. Alright, so again I'm going to start down here plugging in positive numbers. This is going to be 4 times 1/2 cubed. 1/2 times 1/2 times 1/2 is 1/8. 4 times 1/8 turns out to be a half. When I plug in 2, I get 4 times a half squared. That's 4 times a quarter. That's 1. When I plug in 1, I get 4 times a half. That's 2. When I plug in 0, I get 4, because 1/2 to the 0 is going to be 1. 4 times 1/2 to the negative 1. Remember what a negative exponent does to a fraction. A negative exponent simply takes a fraction and flips it. So this becomes 4 times 2 over 1. That's 8. Plug in negative 2. 4 times 1/2 to the negative 2. This is going to be 4 times 2 squared. Again, the negative exponent flips the fraction. 2 squared is 4, and 4 times 4 is 16. And then this one becomes 4 times 1/2 to the negative 3. That's 4 times 2 cubed. That's 8 times 4, that's 32. Okay, so this time we have, I'm going to start at 0, 4, 1, 2, 2, 1, 3, 1/2. And what would happen if I kept picking bigger numbers? 4, 5, 6. 4, 5, 6. I would be taking this fraction and multiplying it more times. My numbers would keep getting smaller, closer to 0. Negative 1, 8. Negative 2, 16, way up off the grid already. And negative 3, 32, even further up off the grid. Alright, so we get a graph that looks like that. So our domain, again, I notice I could plug in negative numbers, 0, and positive numbers. Our domain is all real numbers, and there's a fancy symbol for all real numbers. My range, again, looking at my answer, I only got positive numbers, and again, I'm going to get close and close to this line, but I'm never going to hit it, because no matter what number I plug in here, I'm going to have 4 times a positive number. That's going to be a positive answer. So my range is y is greater than 0. And my asymptote is once again y equals 0. I'm getting very, very close to that line. Something else I want you to notice here in just a minute, but I should say this first. This graph we would call exponential decay. As the x's get bigger, the y's get smaller. The other thing I want you to notice is that the y-intercept turned out to be 0, 4, which was that number right there. And on this problem, the y-intercept turned out to be 0, 1. And remember, there's a 1 right in front of that 3. So, what I'm trying to say is, if you have y equals a times b to the x, your y-intercept is always going to be 0, a. Because when you plug in 0, b to the 0 is always going to be the number 1. And then if b is greater than 1, you get growth. And we saw that in the first example, where b was a number 3, bigger than 1, we got growth. And in this example that we just did, when b was a half, we saw that we got decay. So when b is between 0 and 1, we get decay. And I have to write it this way because remember we did point out that b could not be negative numbers. Okay, so I'm going to pause this video here, and then we'll take a look at some more graphs of some functions that aren't quite exponential but are closely related to exponential.